Hey, welcome everybody to this special webinar here on, we're conducting this on Black Friday here in the US. And then the webinar is entitled 5 SDN Concepts That You've Got to Know. And there's a lot more concepts that you got to know, but these are 5 fundamental concepts. SDN, that's software-defined networking. And we're going to be talking about what is SDN. We're going to be showing you some specific tools that you can use in SDN and why do we need it. And is SDN putting your existing Cisco certifications in jeopardy? We're going to be talking about that as well. But let's kind of get started with the agenda. What are we going to be talking about today specifically? And I've been asked, how long is today's session going to go? Honestly, I don't know. It's going to be, if I had to guess, about 2 hours. I don't want to rush. It's Black Friday. My family is out of the house. They're shopping somewhere. I want no part of that on Black Friday. So I'm just hanging out with you guys and gals. I know we've got Jacqueline and I think some other gals joining us today. But yeah, just want to hang out and we'll take our time. We'll take a bunch of questions. But specifically, here are the 5 things I really want to make sure that you get a good sense of before you leave here today. First of all, what is SDN? I want to give you a solid introduction to what it can do for us. What is the promise of SDN? And the big programming language that we typically use when we're talking about SDN is Python. And people say, can you use something besides Python? Yes, you can. But there are so many examples from other coders and that Cisco gives us that we're going to build on that I'd want you to know Python, because that's almost the de facto standard these days that I would want you to know about. And we're going to have a little session on how to get Python installed on your particular operating system. And then we're going to spend some good quality time giving you basic Python programming instructions. And if you're not a coder right now, no worries. We're going to start at the absolute basics. And we're not going to be a Python expert by the time we leave today. I'm not a Python expert, but we're going to know. Well, here's what I really want to do. Have you heard the acronym of FUD, F-U-D, fear, uncertainty, and doubt? Well, I want to remove the FUD. I want to remove the fear, uncertainty, and doubt surrounding Python programming, because here's what I've seen in the industry. I go to the Cisco Live events and network with a lot of people, and there's a lot of fear out there about, I've got all these Cisco certifications. I'm great at the command line. I can set up route maps with the best of them, but I don't know a thing about programming. Is SDN going to make my skills antiquated? No, we're going to talk about that in just a few moments, but you do need to skill up at this point. It is time to start learning some Python programming, and I don't want you to be afraid of it. Now, here's a fundamental belief about everything we're talking about today. Make sure you get this point. By taking any sort of SDN training, I don't think you're going to come out of that training being able to walk into any situation and know exactly how to address that situation. I've done programming in various languages for several decades now. And you know where I really learn the ins and outs of a programming language? On a project. I'm doing a specific project. I've got this specific need. You bet. I'm going through the documentation trying to figure out what's the function? What's the library I need to import? What's the syntax in order to do this to that? So you're really going to do your major learning when you're involved in an actual project. But you've got to have some basic skills to get to that point. I want to give you some of those basic skills today. And we're going to then take our Python programming skills and we're going to write a program. And that program is going to go out. I don't know if you can hear any humming in the back, but I've got my rack of Cisco gear fired up. We're going to be telnetting into a router with a Python program, and we're going to be reconfiguring that router. So that's going to be a lot of fun. But everything in SDN is not about programming. You've got these controllers from Cisco. You've got the APIC and the APIC-EM. We'll be talking about both of those today. And we want to talk about how we can use the graphical interface on, we could have used either one, but I just picked for today the APIC-EM. We want to take a look at some of the things that we can do through the GUI. It's powerful as well. Now, certainly we can write a Python program to talk to the APIC-EM, to tell it to go out and reconfigure things, but we want to see what we can do from the GUI interface. And we're going to have a lot more going on today as well. This is kind of a celebration of Black Friday here in the U.S. I know we got a lot of international visitors, but here in the U.S. there is like this most massive sale of the year. My wife and 2 daughters, they're out shopping. My wife got up at 4 a.m. this morning, and I want no part of that. I don't want to be around the crowds. I'd much rather hang out and geek out with you all during this time. So what we're going to do today, we're going to have multiple Q&A breaks. And I don't want you to feel like you have to restrict your questions to just SDN. I mean, this is one of those rare opportunities where I get to interact with you guys, and I love it. I love to be able to sort of virtually reach out and connect with you all. So if you want to ask about like a career thing or something else, please feel free to do that. Now, here's the caveat. Let me take a quick look. We've got a bunch of people joining us right now. We've got nearly 200 people on right now, and I'm just not going to be able to answer every question. So please don't get, as my daughters say, don't get butthurt if I don't answer your question. It's nothing personal. There's simply not going to be enough time to answer everybody's question with any quality anyway. So I'm going to be scanning through the questions. I might just not see yours, but I'm going to try to pick out questions that I think will benefit most of the group. So again, please don't get, I got to stop saying that. Don't get butthurt if I don't answer your particular question. Again, it's nothing personal. And I really hope you'll stick around because we're going to be doing multiple giveaways today as well. We're going to have 3 complete video courses that we're going to be giving out. We've got my good friends at Cisco Press. They hooked me up with a free copy. Now, it's a digital copy. I'll email you a link after the fact. It's a digital copy of the Route complete video course from the CCNP Route Switch Track. I've got a code to give you for the T-Shoot complete video course and the Switch complete video course. And when I say complete video course, I mean complete video course. It tells you everything you need to do and get prepared for that exam and be successful on that exam. But I kind of wanted to get started with a discussion. Well, I guess before we get started, I do want to give you the caveat that, or not the caveat, but the strong recommendation that you take notes. We're going to be going through a lot of terms today. I want to make sure you capture those terms because SDN, it's kind of new to a bunch of us. And I want you to write down these terms so you're not thrown when you hear them used in the real world later on. And I know some of you follow me on social media. Some of you are brand new. So let me give you my super quick bio, just so you kind of know where I'm coming from. I've been working with Cisco gear for, wow, is it really approaching 30 years? Yeah, I started back around 1989 with an old Cisco AGS Plus router, if you can imagine that. And I've earned a bunch of certifications in a bunch of different tracks, security and data center and route switching, collaboration and voice when it was that and design. But I got a couple of CCIEs, one in route switch and one in collaboration. And I worked for a Cisco learning partner for about 14 years. In the real world, I was a network manager at a university for a long time. And then I was a network designer down at Walt Disney World in Florida. Talk about a big network. They had like 500 Cisco routers, literally thousands of Cisco Catalyst switches. That was a fun place to work. I've written a bunch of books and I've created a lot of video courses for Cisco Press. You can see I've been a CCA for, I guess now it's like 17 years or so. And bottom line is I'm passionate about this stuff and I cannot wait to help do some knowledge transfer today to help you get a better sense for what SDN is all about and why you need it. Now, let's start off with why I decided to do this. Why is SDN so important? Now, I go to a lot of the Cisco Live events. I remember 2 years ago, or what was it? Has it been in Las Vegas 2 years in a row? I guess it has. But I remember 2 years ago, there was a big stir. So this would have been the 2015 Cisco Live. There was just a lot of talk about SDN. People were thinking that I've worked so hard, I've spent so much money to get my CCIE certification, and now these programmers are going to come along and take my job. We don't want that to happen. And there was just all this, again, the fear, uncertainty, and doubt. People thought that their command line skills were just going to be done away with, and that's not the case. That's not the case. But there was a lot of fuss about that in the early days. And this year at Cisco Live, I think that Chuck Robbins, Cisco's CEO, he really coined a term that I think gives a beautiful picture of this. I remember attending his keynote, and here's a picture I snapped of him. I think I caught him with his eyes closed. This is at the CCA NetVet reception, so try to get a picture of him up close. But I remember at the keynote, he coined a term that he called a hybrid engineer. He explained, and it totally makes sense. He explained that programmers are not going to take your jobs because the programmers, they don't know the underlying syntax. They don't know the underlying routing and switching technologies. You actually need to have both. And he showed this Venn diagram that looks like this. He says, yeah, you've got to have your CLI skills, like maybe you and I have been working on for many, many, many years, but you've also got to have now some programming skills. And in this Venn diagram, this area of overlap, he termed that's where the hybrid engineer lives. That's my goal for each of you. I want you to be hybrid engineers. And the hybrid engineer, they might have their CCIE. I don't want anybody to think that it is no longer a valuable thing to have your CCIE. I think it is extremely valuable to have your CCIE. But in addition to that, I'm just saying, don't stop there. Go ahead and get some programming skills on top of that. That's going to make you that sought after hybrid engineer. That's the engineer of the future. And I want to just kind of set your mind at ease, because I hear that so much. Is it still worth getting a CCA or any of these certifications? Is programmers just going to take over? No. If you're a programmer, learn CLI. If you're a command line person, learn the programming, because you really do need to have both. Now, what is the promise of SDN? What are some of the fundamentals? Visualize this, if you would. Let's pretend that we're an e-commerce company, and this is the night of the big game. By the way, I'm not allowed to say what the big game name is. Did you know it's like copyrighted? I'm not allowed to say the name of the big football game that we have, but you know what I'm talking about. The big game, where the commercials cost a lot of money. But it's the night of the big game, and we're an e-commerce company. And let's say that we're expecting just a flood of traffic coming into our servers to buy our super cool product after our $5 million commercial runs on the big game. Well, in order to accommodate all that extra traffic in our data center, we probably need to spin up some virtual servers. We might need to reconfigure our load balancer to spread the load across those virtual servers. We might need to reconfigure quality of service to give higher priority to that e-commerce traffic coming in and going out in and out of our site. And that's the promise of SDN, because with SDN, we can have programs. We can have programs that are going to reach out, and it can simultaneously reconfigure lots and lots and lots of device. Sorry, I'm just noticing we had somebody saying that they lost audio and video. If that happens to any of you, just please close your browser, reopen it. A nice refresh forgives a multitude of sins. I'd recommend you do that. But yeah, imagine we have a program that could reconfigure quality service. It could reconfigure the load balancer. It could spin up those virtual machines without us having to do it manually, which would be prohibitively administrative intense for us to do that. Now, let's see exactly how that works. We're about to get into some terms, so have your pen and paper in hand, and we're going to go over some terms. First of all, let's consider traditional networks. We've got our traditional routers and switches like we have here on screen, and we've got these different architectural planes of operation. First, we've got the data plane. Now, the data plane, as you might guess, that's the area that's responsible for actually forwarding the packets. A packet comes in on a router, or a frame comes in on a switch, that router is going to consult the IP routing table, or that frame is going to consult the MAC address table. It's going to say, here's the destination. Where do I forward it? Well, based on what the table says, I got to go out this interface. So the data plane is concerned very much about, as quickly as possible, getting a packet from the ingress interface out of the appropriate egress interface. Next up is the control plane. Think of this as where your protocols run. So on a router, you've got routing protocols like OSPF, and the EIGRP and BGP. Those types of routing protocols, things that populate your IP routing table, those live at the control plane. Now, on a switch, it would be something like a spanning tree protocol would be an example. Spanning tree protocol is the algorithm that gives you a loop-free layer 2 topology. And finally, we have the management plane. Now, up at the management plane, this is how we as network engineers are connecting into the device. This is how we're telnetting, or preferably secure shelling into the device. Maybe we're going into the management plane using SNMP, simple network management protocol. Maybe we're using some sort of an SDN protocol, and we'll be talking about some of those. But those are the different planes of operation. Now, how does SDN in general change the landscape? Please take some notes on this. Now, I'm going to talk about SDN generically first, and then I'll talk about how Cisco does it, which is a little different. But generically, we're going to introduce a network controller. And that's going to take us from what we have now, which, here's your first term, a distributed control plane. Notice right now, the routers, the switch, they each have their own control plane in their own device. So it's distributed. Everybody's got their own control plane. Everybody's running their own protocol. But now, with SDN, what we can do is we can introduce a network controller, an SDN network controller, and that's going to allow us to take the control planes and suck them up into the network controller. So now this network controller, this computer running network controller software, it's going to be running OSPF. It's going to be doing the spanning tree shortest path calculation, or that's an OSPF, the spanning tree calculation. And it's going to be propagating appropriate information down to the individual devices. When we have something like this, we are communicating from that controller down to those devices with another term for you, an API, an application program interface. Now, there's a bunch of APIs out there that you'll really get into as you start getting more into SDN. But in general, an API is simply a piece of software that talks to another piece of software. Here we have software on the controller, and it's talking to software in these end devices. So let's say that they both speak the same SDN protocol. OpenFlow is an example of one of those protocols. Well, we could say the OpenFlow protocol to talk between the controller and the switch and the router. That's how we send the information down. That's how we retrieve information from those devices. Now, here's another term for you. If you're going after your CCNA and routing and switching, there's a section of things you've got to know about SDN, and here's one of them. They talk about northbound and southbound interfaces. Notice I said that we had these application programming interfaces, these APIs that interconnect, that communicate between the network controller and the devices at the bottom. Now, those are called southbound APIs or southbound interfaces. Now, why is it called south? Because normally we put the controller in the middle of our topology, like I've done here on screen, and sitting below the controller, south of the controller, in other words, that's where we have our devices. Think of a compass. South is at the bottom. Well, the southbound interfaces connect down to the bottom of this topology, down to the end devices. So we call those southbound interfaces, or the abbreviation is an SBI, a southbound interface. And what we have now is a centralized control plane. Remember, before we had the control plane in each of our devices? Well, now they've been centralized. They all live in the network controller. So now we have a centralized control plane. But what about the specific protocol that's speaking out? The example I gave you earlier was OpenFlow. That's an open standard. There's this open standard called it's the Open Daylight Project, if you want to go Google that and do some more reading on it. But the Open Daylight Project is sort of a vendor neutral way of doing SDN. And one of its APIs, one of its protocols that it uses is called OpenFlow. So maybe we're using OpenFlow as just one example to talk between the controller and the end devices. So we could be saying with OpenFlow, reconfigure your quality of service to do this, reconfigure this interface to do that, change your subnet mask, something like that. Now, Cisco has their own. Cisco can support OpenFlow, but they've also got one called OpFlex. But here we're talking just kind of generically. So if these devices, our end devices, are south of the controller, what's north of the controller? Applications. Applications that perhaps we write using the Python programming language. And as you can guess, the APIs, the communication between the applications and the network controller, those are called NBIs, or northbound interfaces, simply because this is the way we draw it. Applications are at the top. Applications are north of the controller. And the kind of API that we typically use here is called a REST API, or some literature you'll see it called a RESTful API. Now, REST, that's an acronym standing for Representational State Transfer. Sounds complicated. It's super simple. Here's what it means. It simply means that we're going to be using HTTP messages to communicate with the controller. For example, if you go out to a web page right now, you go out to Amazon and you want to pull down the content from Amazon, you might use an HTTP GET request. Or if you're going to send some information about here's your credit card information, you're sending information to populate something on Amazon, you might be sending a POST message. That's what this does. These RESTful APIs can use POST and GET and some other messages to communicate, much like a web browser does with a web server. It can communicate information back and forth between your application, which could be it could be sitting behind the graphical interface that we use on our controller, or it could be the Python programs like we're going to be writing, similar to what we're going to be writing today. And we're going to be communicating down to the controller, and the data that we send is encoded in one of a couple of different formats. You're going to hear these terms a lot in SDN. The first one is JSON. A lot of people pronounce it JSON. Some people say JSON, but I say JSON. That's the camp I'm in. And that's a way to hierarchically represent your instructions. And there's another format that you might be more familiar with called XML, Extensible Markup Language. So XML, JSON, those are the formats, and they're fairly readable by humans, which is great. Those are the formats in which we're going to encode our instructions. Now, by the way, I'll get into this a little bit later on, but let's say that I am running one of Cisco's fancy, super expensive controllers, and I send a command down to the controller to go out to my data center switch and create a new tenant for the data center, a new customer. I could actually see the JSON formatted instructions that just got sent from my APIC. You know what I could do, and that uses something called the API inspector. I could copy and paste that and use that in my own Python program. So once I do something through the GUI, I can take what it did and write my own Python program based on that. That's pretty cool. So those are some basic terms that we've just got to know when it comes to SDN. Now, that was the generic discussion of SDN. Let's talk a little bit more about how Cisco does it. Cisco has two primary SDN controllers. One controller is called the APIC, the Application Policy Infrastructure Controller. And notice what happened to our topology here. The control planes, they went back to the devices, didn't they? They're no longer in the controller. Cisco doesn't do centralized, the centralized control plane. It does a distributed control plane where it remains in our devices. And I've read a white paper or two on why Cisco considers that to be a safer, a more reliable approach. And I mean, these devices were meant to run OSPF. I don't think we're overtaxing them by making them run their own control plane. And we no longer have a central point of failure where if that goes down, suddenly our routing protocols are down. I actually think Cisco's doing it right. And our APIC can send instructions down. I've just thrown 3 devices. Imagine reconfiguring hundreds of devices in a data center to respond to some changing network condition, like running our commercial on the big game. That's what we can do with an APIC controller. But the APIC is typically found inside of the data center. You're not going to really see that much, if at all, out in the enterprise network, like within a building connecting routers and switches throughout a campus. There's going to be a different controller for that. And here's why. Your data center devices, so there are some of Cisco's Nexus devices, they support some of these southbound APIs like OpFlex or OpenFlow. They speak SDN. You could think of it like that. But I mean, I'm looking here in my studio. I've got a rack of equipment, and I've got some Catalyst switches. I've got some ISR2 routers. I mean, they're good, decent devices, but They have no clue about SDN. They don't know OpenFlex from or OpFlex from OpenFlow. Can they be included in some sort of an SDN solution? Absolutely. To do that, we can use Cisco's other major controller, and it's called the APIC-EM. That's the Application Policy Infrastructure Controller Enterprise Module. You're going to use this not so much in the data center, you're going to use this in the enterprise. Anybody want to guess? I'll tell you in a moment. Anybody want to guess what APIs we might be using to communicate from the APIC down to the here's your hint, down to the management plane of these devices? What do you think they might understand at the management plane? Now, still, the APIC can reach out and it can reconfigure multiple devices at the same time. It can reconfigure policies. Notice it's the Application Policy Infrastructure Controller. Yeah, we can say that an application, and you'll see this later today, that has specific needs. And here's a term that I really want you to know. Cisco says there at the northbound interface, Cisco says that SDN adds a layer of abstraction. A layer of abstraction. Now, what that means is, let's say that we're reconfiguring quality of service, and you'll see that later today. I'm reconfiguring quality of service, and if I were doing that at the command line, I'm going in and I'm creating class maps and a policy map and applying the service policy command and setting up low latency queuing and class-based waiting for queuing. That's a lot of work. And most people don't know how to do that. So this layer of abstraction comes in where you've got this nice, beautiful GUI interface, which has a list of all these applications, and you've got these three columns. You've got programs that are business relevant. You've got programs that are business irrelevant, and just kind of your normal programs. And you can just drag and drop all these different programs into what you consider to be business relevant or not. And then it will, the controller, the APIC-EM, it will go out and it will deploy a very robust quality of service configuration to your end devices. You don't have to know the first thing about a class map. You just have to know what's important in your environment. That has abstracted all the underlying CLI from you. You don't have to know all that stuff. It's good if you do, but you can have people that just understand the business needs without being a QoS expert go in and use these controllers. Okay, now let's see what people were saying here. Yeah, we've got some people saying SNMP. That's one of them. You could also use Telnet. You could use Secure Shell. You could use SNMP. Pretty much anything that we currently use to connect into the management plane, our APIC-EM can use for our traditional network devices. So just to sum up what we've talked about thus far, we said that SDN is going to dramatically scale our ability to make quick changes to lots and lots of devices. We don't have to do it one or two or three. We also have that layer of abstraction where we don't necessarily have to understand all the underlying commands. We need to know what's happening, but we don't necessarily need to understand all the underlying commands. And we talked about a bunch of terms, and we said traditionally with SDN, we centralize the control plane, but Cisco doesn't do that. Cisco leaves it distributed. And Cisco had two main controllers. Remember the APIC? That was seen in the data center, and that's part of Cisco's ACI solution. There's another term for you. That's the application-centric infrastructure, suggesting that the application is in charge of what happens on the network, not so much routing protocols, but your application is dictating what happens in your network. And we had the APIC-EM for your enterprise. Now, the next big topic we want to jump into, and if you joined us late, let me just remind everybody that we are going to be taking multiple Q&A breaks, but I've got those strategically scheduled throughout the session. I'm seeing a lot of questions coming in here out of my peripheral vision. Not going to be able to answer those right now. I hope you understand. I'll take a bunch of questions when we get to our first Q&A break, and that's going to come up in just a bit. But when I started studying this stuff back in January is when I got into it hardcore, because in fact, if you read my blog, my very first blog post of the year on January 1st is, I remember the title, it was called, "It's Time to Pivot." And I was sounding the call that, okay, let's all go learn Python. Let's all go learn network programmability. It's not enough. It's necessary to have our existing Cisco certs. It's necessary to know the CLI, but we need to skill up, and we also need to learn some programming. And as I started learning it, I got very confused. I just got overwhelmed with all the terms and this controller and that controller, and you can do it this way, and here's this API. So here's what I did. After studying this stuff and working with this stuff for months, I thought, I've got to have a better way to visualize this, because right now I've just got acronyms floating around my head. So I came, this is something that I designed. You might want to take a screenshot of it. Might help you as well. This is what I call my network programmability framework. Now, the underlying goal of everything we're talking about is to do some network device configuration. And I think of it, and yes, you might say, oh, Ansible's not on here. No, this is not an all-inclusive framework. This is the basics. This is what you need to know to get in the game. This is what I would want you to know to start. This is going to allow you to start working on your first project once you get good at all these areas. And then you're going to learn what you need to. OJT, you've heard of on-the-job training. You're going to learn most of your SDN knowledge through OJT, on-the-job training. But this is the foundation. 3 main ways that we can reconfigure our network devices. One is to use the APIC controller, typically in the data center. Another way is to use the APIC-EM controller, typically in the enterprise. Another way is to use a Python program that can talk directly to a device. We'll do that today. And notice, let me just briefly touch on some of these. Take a look at APIC controller. Now, I have a note up at the top of this Venn diagram that this is typically going to be used for data center devices, maybe using a protocol like OpFlex. And some of the tools we might use, oh, here's a cool one. It's kind of small print on screen. Hope your Facebook Live is set to high definition right now so you can see all this. ARIA, love ARIA. ARIA lets us take the graphical interface or the API inspector. It allows us to take that JSON formatted instruction set that the controller is sending to our control, that the controller, or excuse me, that is being sent out to the controller, and it gives it to us. And it allows us to put that in this ARIA program, and it creates a Python program for us. You input the JSON formatted code that you get from the controller, from the GUI interface, and you say, create a Python program that's going to do this. Now, obviously, you've got to go in and change a couple of things like IP addresses. So there's a couple of things you got to modify, but talk about a time saver. ARIA pretty much writes your program for you. There's another one that I listed here called Visor. Now, when you really get into working with APIs, there are so many APIs on these controllers. I'd be shocked if anybody knew all of them. So if you're investigating using a particular API, this is a graphical interface. You point to the IP address of your APIC, and I think it's /Visor, if I'm not mistaken, and you get this GUI interface where you can, it's like a kind of a query. You can query different APIs, and you can see all the syntax and everything involved with that API. It's kind of an online research tool. Oh, and I love the next one, the ACI toolkit. Most of the time, you're not going to be writing your program from scratch. Most of the time, you're going to take some existing code that you've written or that somebody else has written or you got on somebody's GitHub, and you're going to modify it for your needs. You can download Cisco's ACI toolkit, and it has dozens of programs, Python programs, that do all sorts of things for routers and switches. Modify it for what you want to do. That is a massive, massive time saver. And it also gives you a lot of education as you're looking through their code. It gives you an education as to how to do something you're wanting to do. Now, at the APIC-EM controller, again, we can use Telnet, Secure Shell, SNMP to talk to these network in-network devices, traditional network devices. Now, something I'm going to demonstrate for you later today is doing a Python program that talks without a controller. We don't have to have a controller. That adds scalability, certainly, but I can have a Python program that reaches out and talks directly to a device. I can add a library to Python like telnet lib. I'll show you how to do that. And that's going to allow us to telnet into a device. Or if we want a secure shell, Couple of libraries we could add: NetMiko, Paramiko. Oh, and here's a big one you hear a lot about: Telnet, NetMiko, Paramiko. All that's great, but the program has to know the syntax of the router. Config T, interface fast Ethernet 0/1, IP address. It has to know the syntax. You have to program in the syntax that router or that switch is expecting. It gets a lot more flexible with something called netconf. With netconf, we're sort of vendor interoperable here with devices that support what are called Yang data models. Now, let me give you just a super simple example of just thought of this. Now here I've got my brand new, just got this a few days ago. This is my iPhone 10. It's not an iPhone X. Don't call it an iPhone X. It's an iPhone 10. But I could create a Yang data model to represent an iPhone. One part of that Yang data model could be the iPhone, the model. So like 8, 10, 6, 6 plus, 7, 7 plus. Another part of that Yang data model could be the screen size. Another part of the Yang data model could be the memory. How much storage does it have? And I could represent any iPhone by populating that Yang data model. Now, here's what we can do with a network device. Let's say that I'm configuring a Juniper device or a Cisco device or a Cisco switch. If they support these IETF, these industry standard data models, then I can say, I want to go in and configure the first gigabit interface with this IP address for full duplex. I want to set the MTU this way. And I can just put that information in the Yang data model. I don't have to know that I have to first do a config T and go into interface configuration mode. I just populate the model, and netconf is going, well, we encode everything in Yang. We want to do these settings, and Juniper can understand it. HP can understand it. Cisco can, anybody that supports Yang can understand what we're telling it to do. We encapsulate that inside of XML, and then we have this layer 4 protocol called netconf that's going to send the instruction out to Juniper, to Cisco, and say, set your first gigabit interface to this. We didn't have to know any syntax. We just had to know how to populate that Yang data model. That's powerful stuff. More on that in just a bit. But I want to, we've talked a lot about theory so far. So what I want to do now is I want to actually get us in to doing some Python programming. And when I go live, I'm going to turn my camera off. I don't want to obscure anything on the screen as we're going through the demo. So 1 second, I'm just going to turn off my camera. And let's go over to python.org. This is where you're going to download your Python software if you don't already have it. Now, I happen to be running Mac. I'm running Mac OS. It's High Sierra is the particular version that I'm running. But what you with Mac for the past several versions, as far back as I can remember, they have included Python. You can go to the command line and you can type in Python, and suddenly you're in a Python shell. Linux, you might have Python installed there. If you're running Microsoft Windows, you probably need to install. You know what? Even though I've got Python installed on my Mac, I went ahead and installed it here anyway, because the version I have on my Mac is Python 2.7. I went in and I installed Python 3.6, because when you're using somebody else's code, I noticed that a lot of the examples that Cisco gives us, it's 3.6. Now, some stuff, if you're using that Cobra SDK, yeah, that's going to be using 2.7. So I want to be able to use both. You can run multiple concurrent versions of Python on your system. That's what I'm doing. But you could say that you want to download Python 3.6, or we could go to the downloads page and you can see all the different platforms that it's available for. You could say if it's Mac or Linux or Unix or Windows. And they even have some others if you dig far enough. They have a version for MS-DOS if anybody's still running that. But you download it, you install it, and then you can go out to a command line. Now here I'm at a command line, and I'm going to type in Python. Now if I just type in Python, notice it tells me I'm currently running version 2.7, well, 2.7.13. I'm not really concerned about that that third field. I'm running 2.7. That's what came with my Mac. You know what? I don't really want to run that, honestly. I do most of my Python coding in 3.6. Some of the syntax is quite different. I want to use 2.7 sometimes, but usually I want to run 3.6. So let me show you how I can exit this and then get into 3.6 after you go install it from python.org. It's not .com, it's .org. Keep that in mind. Now, I don't just say exit. Exit is actually a function in Python. And a function usually has open and close parentheses. So I have to say exit, open and close parentheses. That kicks me back out to my command prompt. If I want to run Python 3.6, then I need to actually say Python, no space, 3.6. Now you can see I'm running 3.6. That's what I installed from the python.org site. Now, Python itself, it's not just used for network programmability. I'm going to be giving you some book recommendations later on today to do some further study in this stuff. But it's used a lot for automation. It's used for math. If you're like a math major or an engineering major in college, you can do a lot of math stuff. It's sometimes used for web development. I've seen it used for games. But here we're focused on how it can reach out and talk to our network devices. Now here, notice I'm at this prompt. It's 3 greater than signs. Again, please be taking some notes as we go through this. I'm going to just do some basic math right now. This is one of the things I love most about Python. We're now sitting at what's called the interactive interpreter. I can say 5 and give an asterisk, which represents the multiplication function, and I'll say 5 times 5, and it comes back and says 25. It's an interactive interpreter. I've programmed in various languages over the years, including, I remember C is the first one that came to mind. When I used to code in C, I would write my program, then I would have to compile it. I'd have to make, that was the command. I would have to make the program to compile it, and then I would run it. And then I would find out if I had a syntax error or not. That was kind of a pain. I love the fact that I can do all this testing, all these commands right at this interactive interpreter, and it gives me immediate feedback. Now, sure, I'll show you how to create a program later that we can run, but we can do a lot of stuff right here at the interpreter. So let's just play with this for a while. We can assign a variable. Like I could say the variable x equals 4, and then I could do a mathematical operation. I could say, okay, what is x times 3? 12. You see, it remembered that x equaled 4. And notice that I said x equals 4 with no spaces. I could have said x space equals space 4. That's perfectly fine. It does not pay attention to spaces. And single quotes are the same as double quotes, so no worries there. If I want to do division, I could do 12 divided by 4. If I want to do plus, obviously 12 plus 4, 12 minus 4. Here's the one that might not be obvious, is raising something to a power. Now, my first guess as I was learning this is I'm going to use the caret symbol to raise something to a power. That's not right. It was actually two asterisks. So it's 4 star 2. That says 4 raised to the power of 2. 4 squared is 16. Now, I've just been entering integers. Now, an integer, remember, that does not have a decimal place. And that's one data type. There's a term for you, a data type that Python recognizes. As you're working with Python programs, you need to understand different data types. If I want to know what data type I'm dealing with, here's a function that we can use. I can say type, and inside parentheses, I can put what I want to know the data type of. If I say type 4 in parentheses, it comes back and says, oh, that's a class of int, meaning an integer. It does not have a decimal place. If I say type 4.5, or it does not have a decimal, 4.5, it does have a decimal. It's not an integer. So what's this one going to be? It's going to be a floating point data type. Notice it says float. What about a string? I can enclose strings in quotes. Again, single quotes, double quotes, doesn't matter. I could say type, and then in parentheses, I could say Kevin. And it says str. So that's a string data type. Now, how do I print something to the screen? Here's another function for us. We've talked about the exit function. We've talked about the type function. Here's another function that's going to show us some feedback on the screen. I can say print. And then inside of my parentheses, if I want to print a string, I need to include that string in quotes. So I can say print in quotes my name, Kevin Wallace. Let's try this. I'm going to assign some variables. I'm going to say first name equals Kevin in quotes. Now, by the way, notice how I named that variable. I said first name and the N is uppercase, but the F is not in uppercase. There's no rule. I mean, it's going to work, but it's a common practice to name your variables like this. This is called a hybrid case. There's one called camel case, and there's different kinds, but this is called hybrid case. And what we do here is we capitalize the first word, or we capitalize the first letter of every word in the variable name, except the first one. So we didn't capitalize the F in first, but we capitalized the N in name. So first name equals Kevin. Now, when I print this out, I want to print Kevin, then I want to print a space, and then I want to print my last name. So I'll create another variable. I'll say space equals it's just a space in quotes. Then last name, I'll say in quotes is Wallace. Now I want to show you how we can concatenate is the word, how I can stick these end to end and print them all out at once. I can say print, and notice I'm not going to use a quote here like I did before. I'm just going to reference the variables. I'm going to say print my first name, whatever's in that variable, plus the variable of space, plus the variable of last name. And when I press enter, it prints out the contents of those three variables. It prints out my name. Now, let's consider another data type. This is the Boolean data type. That's a fun word to say, Boolean. And it tells us if something is true or false. This is going to allow us to test different conditions. For example, I could say type, and I say true. Now, by the way, case is important here. Notice the T is capitalized and nothing else is. That's what it has to be. You cannot mix the case here. It's a capital T, capital F for false. It says BOOL. That's a Boolean. It's going to be a Boolean data type. Now, I want to let's use a Boolean operation to test a condition. It's like if then. I could say, does the first name variable equal Kevin? Yes, it does. So it should return a Boolean value of true. Let's try it. I can say first name, and if I'm wanting to test a condition, instead of giving a single equal sign, that's how I assign a value to something. I use two equal signs. First name equal. I'm saying, does this equal? And then in quotes, I'll put Kevin. And it comes back and it says true. Yes, it does. That's the result of my evaluation. Now, if I said, does the first name equal Wallace? No, it doesn't. So it's going to come back and it's going to say false. We could do this with numbers. I could say, if I want to test if something is less than or equal to, I could say, is 5 less than or equal to 4? No, it's not less than or equal to 4. So it's going to return a value of false. I could say, is 3 less than 3? No, 3 is not less than 3, but is 3 less than or equal to 3? Yeah, it sure is. Now let's look at, one other one. We can see if a letter or a number lives inside of a variable. Here's what I mean. Right now, I've assigned the last name variable a value of Wallace. If I want to see if there's the letter W in that variable, I could say W, in quotes, in last name. I'm saying, is the letter W in the variable last name? And it is. And it comes back and says true. Now, let's excuse me. Let's look at conditionals. You might have heard this referred to as if-thens. We don't actually use the term then here, but we can say if a condition is true, do this. If it's not true, do something else. For example, I could say if the number 10 is less than the number 100, I want to do something. But here's what we do. I have to put a colon here. The colon says I'm not done yet. Notice when it goes down to the next line, instead of getting the greater than sign prompts, I get a ... It says, okay, you're still typing here. I want to say if 10 is less than 100, then I want to print a message. I want to print a message that says 10 is less than 100. But here's the big deal. It's only going to, if this is a true condition, what it's going to do, I need to indent it. Now, I usually use 4 spaces. I want to do 1, 2, 3, 4 spaces, and then I'll give my instruction. I'll say print the string of 10 is less than 100. Close quote, close parentheses. Now, you can use tabs, but whichever you choose to do, be consistent. You're going to get errors if you use spaces some of the times and tabs some of the times. Does anybody watch the TV show on HBO, Silicon Valley? There was one episode where they just got in this huge argument over tabs versus spaces. That reminded me of that episode for some reason. I'm a space person personally, but I don't hold any offense if you're a tab person. So we're saying if this condition is true, then do this. Now, I don't have any more lines to enter right now. I don't have any more lines, so I'm just going to press enter. It does the evaluation. It says 10 is less than 100. Okay, well, let's expand this a little bit. Let's do an example where different things are going to happen based on a true or false value. Now, I do a lot of work in the collaboration space with voice and video, Cisco IP phones. And when we're setting up a switch port, oftentimes we have what's called a native VLAN that carries data from a PC plugged into the phone. And then we've got the voice VLAN that carries the voice traffic coming from the phone. So I'm going to assign some variables here. I'm going to say my native VLAN, since VLAN is an acronym, I'm going to make it all uppercase. I'll say my native VLAN equals 1, and I'll say my voice VLAN equals 100. Actually, you know what? Usually the native VLAN and the voice VLAN or the data VLAN are the same. I'm going to do this. I'm going to say the native VLAN is VLAN 1, the data VLAN. Again, normally those are the same. I'm going to say it's 100. Now, I want to test to see if those are equal. Here's what I can do. I'm going to say if the native VLAN equals, remember, an evaluation uses 2 signs. If it equals data VLAN, and I give a colon because I've got more stuff to come, and I have to indent 1, 2, 3, 4, then I want to print the message that says the native and data VLANs are, let's see, if they're, I'll say they're the same. They're the same. If they're not the same, I want to give a different instruction. Now, my other instruction, it's going to begin, I'm going to say else, colon. So I'm going to say if these equal one another, then print this message. Else, enter. Let's see, what was my syntax error there? Let's see, else. Oh, not sure what I did wrong there. Let me try that again. Do the if native VLAN equals that, and then my spaces. I'm just missing something super simple here, I'm sure. Oh, and the print line. Oh, you're right. I forgot to do a close parentheses. Thank you for spotting that. Yeah. I need a close parentheses. So we're just going to start over here. How about that? Yeah, I missed a parentheses. Thanks for pointing that out, guys. That would have taken me a few minutes to figure out. So I'm saying, all right, native VLAN is 1. Data VLAN is 100. If the native VLAN and the native VLAN equal one another, then print with a closed parentheses this time. Print that. Else, that's much better. Indent 1, 2, 3, 4. I want to print something else. I'll print the native and data VLANs are different. Close parentheses this time. I'm done, so I'll press enter. And it says, yep, I evaluated them. They're different. So that's how we can do one thing based on if a condition is true. I can do something else if it's false. Let's do another one of these where I want to do a compound Boolean decision. Now, in the voice world, again, oftentimes we have a layer 2 quality of service marking. It's called a class of service or a COS marking. If normally COS equals 5 and DSCP equals 46. I want to see, now if both of those are true, then I'm probably looking at a voice packet. So I'm going to say if, well, first of all, let me assign the values. I'll say my class of service equals 5. My DSCP value equals 46. Now here's my evaluation. I will say if COS equals 5. Now here's my compound instruction. I can either use the word and or. I'm going to say and. I need both conditions to be true. If COS equals 5 and DSCP equals 46, then, whoops, I typed in 36. If it equals 46, then I want to do something. So I'm going to do a colon and indent 1, 2, 3, 4, and I'll say print in quotes. This is a voice packet. Close quote, close parentheses, else 1, 2, 3, 4, print. This is not a voice packet. And I'll press enter. It's true. Both of those conditions were true. So this was classified as a voice packet. So I hope you're, we'll do a little bit more here, but I hope you guys are getting the sense that this is not, it's not too bad to get started. You can do some useful stuff. And again, we'll actually create a program later and run a program. So we're not doing everything at the interactive interpreter. But I want to share with you another data type now for your notes. This is called the list data type. I remember this one from another programming language or two. We used to call them, I think I used to call them an array from some other language in the past. I'm not sure what it was, but I think I used to call this an array, but they call it a list here in Python. And it's kind of a matrix. It's where we can have one variable store multiple values. It works like this. Let's say I want to have a variable that represents my inventory of Cisco gear. I might say the variable inventory equals, and a list is going to be in square brackets and in quotes because these are strings and they're going to be comma separated. I'm going to say I've got a Catalyst 3750, close quote, and it's comma separated, so I do a comma. Another item I have is a Catalyst 2960, close quote, comma, and in quotes, let's say I also have a 2911 router, close quote, comma. I'll do one more. And let's say that I've got a 7965G IP phone, close quote, and close my hard brackets or my square brackets. So I've now created a variable that contains lots of values. It's the inventory variable. Now, if I want to make sure that this is really a list variable, I could say type. Remember the type function? I can say what type of variable is inventory. It says it's a list variable. Okay. I could see how many items are in the list by saying, here's another function for your notes. LEN, I'll say LEN inventory. And it says 4. It tells me I've got 4 values, which I do. I have 4 items in my inventory. Now, by the way, that LEN function, it could also be used on something like a string. I could say, what's the LEN of Kevin? And it's going to tell me the number of characters in Kevin. But if we're applying this to a list variable, it's how many items are in that list. If I want to show all the items, I can simply type in inventory. There they are. But oftentimes what we want to do is we want to extract a particular item from the inventory. I could say, I want to see if I have a Catalyst 35 or 3750 in my inventory. So I could use that N operation that we talked about earlier, that IN operation. I can say, in quotes, Catalyst 3750, close quotes, and give the keyword of N. Is that N the variable of inventory? True. Yes, it is. If I want to look at a specific item in the list, here's a big deal. Numbering starts at 0. So that first item, the Catalyst 3750, it's item 0. I can say, show me inventory item, and in quotes, I'll put, or in brackets, I'll put 0. And it says item number 0, which is the first item, is Catalyst 3750. If I want to get the second one, well, that's going to be number 1. So I would say inventory 1 in brackets, and it's going to tell me the Catalyst 2960. Oh, we could also start at the end. I could say inventory and do a -1 in brackets. That's going to give me the very last item. This should give me the 7965 GIP phone. If I want to see the next to last item, which would be the 2911 router, that'd be a -2. Now, one of the cool things is I'm showing you a bunch of examples here. What I highly encourage you to do is watch the replay of this. I plan on posting this. On my YouTube channel next Tuesday. I'm going to cut out. We had a little pregame chat with a bunch of our people that showed up early. I'm going to cut all that stuff out. But I'm going to post that, I think, on Tuesday. I would encourage you to use Python on your computer and just go through these exercises. Learning comes through all this repetition. What else can we do? Here's a big one. Looping. Let's talk about looping. One more thing on the list, though. Almost forgot. Let's say that I want to add something to my inventory. I could say inventory, and then I could say dot append. I'm going to append. I'm going to stick something to the end of this inventory. What is it? Well, in parentheses and in quotes, it's going to be a CUCM server. I'm going to append that item to the end of my inventory. Now, if I say inventory, you can see it's been added to the inventory. Now, let's take a look at looping. We can say, here's a cool one. I love this. We can say for item. Now, this is a variable that I'm just making up. I'm going to say for item in inventory. In other words, we're going to go through this loop, and each time we're going to pick the next item in inventory. First, we're going to start out with the Catalyst 3750, and then we're going to go to the Catalyst 2960. We're going to do whatever we're about to do until we run out of items. That's what the for item in says. So when I first run this, the variable item equals the first item in the inventory. It equals the Catalyst 3750. The next time we loop through this, it's going to equal the next item. Item is going to equal Catalyst 2960. Now, what am I going to do? Well, what I want to do is to print. Now, I need to do a colon here, just like the if else. I'm going to indent 1, 2, 3, 4. I want to print whatever the current value of item is. And I'm done. So I'm going to press enter, and it's going to loop through this thing, 5 times? That's what it did. And it printed out each time item equaled a different value. And each time it printed out that value. We printed out all the items in the inventory. Let's combine this with the if statement. Let's again say for item in inventory, colon, 1, 2, 3, 4. Let's use the if statement. I want to check to see if the word catalyst is in the item. Now, I've got a couple of catalysts here, so I should get 2 results. I'm going to say if catalyst is in the variable item, colon. Now, I'm going to do 2 indentions now, so it's going to be 1, 2, 3, 4, 1, 2, 3, 4. Then I'm going to say I want to print that item. And yeah, I think I'm done. So it's going to go through all 5 of those items, and it's going to evaluate to see if the word catalyst is currently in the variable item. If it is, it's going to print it. And we get 2 results, just as predicted. Pretty awesome stuff. What else can we do here? I mean, we could go on for a while. I want to give you some of the really cool stuff to use, though. Let's see. Let's get out of this environment and let's actually write a program. I think that'll be fun. Let's say exit, and again, it's a function, so I do open and close parentheses. Now, I can go into this this environment to write a program. It still gives me an interactive interpreter, but it's more of a programming environment. It's called IDLE, I-D-L-E. That stands for Integrated Development Environment. Now, if I just type in IDLE and press enter, it's going to run IDLE 2.7, what was installed on my Mac by default. I want to run IDLE 3.6. I'm going to say IDLE, no space, 3.6. And it's going to open up. It's going to open up a separate window. And it's somewhere. Oh, it's in a different screen. Let me pull over here so you can see it. Here is the IDLE window that it just opened up. Now I'm going to create a new file under here. Let's see. I'm going to say new file. I'll just kind of put these side by side so we can work with them together. So here in my right pane, I've got this this IDLE window. And this is an interactive interpreter. I can do like I did before. I could say 4 times 4, and it tells me 16. So I can do my little testing over here. But in the left-hand pane, I want to actually write a program. And I'm going to save it. I'm going to go ahead and give it a name. I'll say save it as, let's see, save it as, I'll go into the Python directory. I'll say BF for Black Friday demo 1.py. The extension of a Python program is typically .py. So that's the name of my program. Now let's actually write a program. I'm going to say, now if you've done many programming languages, what's the famous program that's the first program you write in any programming language? Go ahead and chat that in if you would. Yeah, it's Hello World. Hello World. That's what we're going to do. Just start out really simple. Then we'll get a little bit more in depth. Yeah, Danny knew what that was. First one with the correct answer, as did Nate and Ryan and a bunch of people. All right, let's do a Hello World program. I think that'll be fun. I'm simply going to say print, and then parentheses and in quotes, Hello World, close quote, close parentheses. Oh, and I love the way it does the color coding. Remember earlier, I forgot to do my close parentheses. It would give me a warning about that. It would show that everything was still in green until I gave that close parentheses. That would have helped me find it quicker than. But you guys were pretty quick to help me out. I appreciate that. Okay, I think we're done. I'm going to save this. Under File, I'll say Save. And then under Run, I'm going to say Run Module. And you're going to see the results over here in this IDLE window on the right. I'm going to say Run Module. And it comes back and says, Hello World. Well, that was fun, wasn't it? It's not terribly useful, but that's our first Python program. Let's try to do something that's a bit more useful now. Let's write a program that will let me, let's use that inventory example. Let's do something that will let me add an item to my inventory. So I'm going to just kind of erase this. Let's erase that. And I'm going to start out kind of like I did before. I'll create a variable. I'll create an inventory variable, and it's going to be in brackets. And I won't do as many as I did before. I'll do a catalyst 3750, close quote, comma, quote, catalyst 2960, close quote, comma. I guess I am doing as many as I did before. 2911 router, close quote, comma. And then I'll do a 7965G IP phone. Close quote and close square brackets. I've now declared my variable just like we did earlier at the interactive interpreter. Now what I want to do is say print, and I'll print out the current value of the inventory. I'm going to say in quotes, the current inventory is colon, close quote, close parentheses, and I'm going to print whatever the value is for inventory. You see, I put quotes around strings, and it prints out exactly what's in the quotes. But for variables, I just say print the variable, print whatever's in inventory. So this is like going to be the before. Here's what the inventory is before I add something. Now, here's another function that we haven't talked about yet. Here is a function that's going to ask me, what do I want to add to the inventory? It's the input function. And I'm going to use a variable of item. I'm going to say, whatever I type in is going to be assigned to the variable of item. Now, here's that function. I'm going to say input, in parentheses, and by the way, this is different syntax. This will not work in Python 2.7. That's one of the big differences. But for 3.6 or 3.x, here's how it works. I'll say enter new, need to put this in quotes. I'll say enter the new inventory item, colon, space, close quote, close parentheses. That's going to ask me, it's going to come up on the screen with a prompt for me to enter the new item name. Now, when I get that, it's now going to belong to the variable of item. Do you remember how we appended to the inventory before? We said inventory.append, and then we appended whatever was in parentheses here. Well, I'm going to append the variable of item, which is going to be whatever I had typed in. Now I'm going to print the inventory again. I'm going to say print, quotes, the current inventory is colon, quote, and I'll say print inventory. I think we're done. I need to save it. I'll say file, save, run module. And over here, it says, here's the current inventory, and it shows me what my original inventory is. And it says, enter the new inventory item. Let's enter an adaptive security appliance. I'll say we're adding an ASA to the inventory, and I'll press enter. And now it says, now the current inventory is, and you see the inventory, and it has appended ASA to our inventory. So let's just kind of sum up what we've done here during our Python discussion. We learned about data types. We talked about the integer, the floating point, the Boolean, the list. We saw how to do conditionals, where if this happens, then do this. If not, do something else. We saw how to do looping. We saw how to see if a value was in a string. We saw how to get user input. We saw how to search a list, how to append to a list, how to print something to the screen. And we contrasted the interactive interpreter with how we could write a program and how to use this idle. Obviously, there's a lot more to Python. I'm going to be giving you some book recommendations later on. But I think this is a decent start. You can get out and you can play with this. Again, after class, next Tuesday, be looking at my YouTube channel. It'll be posted around 11 a.m. Eastern time, I think, if this records correctly, that is. And yeah, you can watch this whole thing over again. Let's continue on now. Now that we've learned a bit about Python, let's write a Python program that's going to connect directly to a network device and do some configuration on that device. So let's, first of all, hop over to, here's a Google search that I've done here. In order to make Python telnet, now, again, in that network programmability video course that many of you bought, you're going to learn how to do this in Telnet. You're going to learn two ways to do it using Secure Shell. Just to keep it simple, I'm going to do it in Telnet. Just to show you. There's a library that we can add to Python to increase its potential or increase what it does. And it's called Telnet Lib or Telnet Lib, depending on how you want to pronounce that. So I'm just doing a Google search for Telnet Lib or Telnet Lib. I'm just going to pick the first result. And notice it shows the Python version up top. It's 2.7. I want to do it in 3.6. I'm going to drop this down, and I'm going to change this to 3.6. You're going to love this. Remember I said that rarely are we going to be writing a lot of programs from scratch. We're going to be leveraging what people have already done. We're just going to be making some modifications. So take a look at this. I'm going to go down to the bottom of this. Pardon the scroll. I hope I don't make you sick as I'm doing this. But down at the bottom of this page, there's an example. here's a simple or an example telnet piece of code. And this is for logging into a Linux host. We're going to modify this a bit. I'm going to make a copy of this, and I'm going to go paste it in my text editor. My text editor, and you can use whatever text editor. I happen to be using Text Wrangler, which I'm using on my Mac. Now, before we do anything, I want to see the actual procedure of how, what I want to do. I'll keep it simple. The objective is log into a router, change the host name. So before we do it programmatically, I want to see how I do it manually. So let's go over to a terminal window. If I can find my terminal, where'd it go? There it is. Let's go over to a terminal window. And I'm going to telnet, and my router is at, I'm going to telnet to 192.168.1.77. Okay, it's going to say username colon, and my username is Cisco. And it's going to say password colon, and the password is Cisco. And it's going to bring me to the R1 prompt. Okay. In order to make a change, I need to go into privilege mode. So I'm going to say enable and press enter. It's going to say password colon again. I'll type in Cisco and press enter. I need to go into global configuration. So I'll say configure term. Now I'll say host name, and I'll say new host name. And it immediately changes. I can now say exit. And if I want to save my change, I'll say copy running config to startup config. And I have to press enter, and we're done. That's what I want the program to do without us doing it. So instead of doing all that, I could just have the program go do it. Now, let me change it back real quick. Let's say it's, I'll say that the host name is R1. But I think we know what we need to do now. And I'll just leave this window up, and let's go back over to our program here. We need to make some changes. First of all, I need to change the host. The host is not going to be local host. The host is going to be the IP address of my router, which we know is 192.168.1.77. And I could make this say whatever I want. I don't like this wording. Enter your remote user. I want to make it look like somebody's actually connecting to a Cisco router. So what I'm going to do is say, I'll just say username, colon, space. Now, next is a function. It's the get pass function. It's part of, you see, we're importing this library, and we're importing this other library. This library is going to prompt us for a password, and it's going to securely, we're using telnet. It's not going to be that secure, but it's going to pass it to the host. So we're using this new library function of getPass, and I'll leave that alone. But what did it prompt me for? It didn't say login, because it says read until. It's waiting for the router to come back with a prompt, and it's not going to be login. If I recall, it was username colon space. So when it says username colon space, I'm going to enter that. It's then going to ask for the password. That all looks correct. Now, here's where things change. Notice that once they get connected, they're giving an ls command, because this is in Linux. The \n, that's a hard return. So I'm going to say enable. I think that's the first thing I had to type in. Enable \n. In fact, let me make a copy. These tn.write commands, those are commands I'm writing to my host. So the first thing is I say enable, then I'm going to give the keyword of Cisco, because it's prompting me for my enable password. Then after I do that, I have to go into global configuration mode. So I'll say comp term. Next, I want to give that my configuration command. I'm going to say host name is, I'll say HQ router. That's going to be my new host name. So we know it's worked if the host name changes to that. Then I need to say I'm done doing my configuration. So I'll say end \n. And then I want to save my config. So I'll say copy, run, star. and I have to press enter. So that'll just be a \n to say, yeah, I want to press enter. And then I'm done. So I'll give one more command to say exit. I don't think I missed anything. If you guys spotted something that I missed, please let me know. So it's going to give those commands in the background, and then it's going to print out this bottom print command. It's going to print out in ASCII format this conversation that it had with the router in the background. Now let's save this so that we can run it. I'm going to say save as, and I'll save it as, let's see, Diver Down, or Black Friday. I'll say BF telnet.py. So my program is going to be called bftelnet.py. Let's save that. Let's go out to a prompt. I'm going to go into my Python directory where it lives, and I'm going to say Python 3.6, that's the version I want to run, and I'm going to say bftelnet.py. And it prompts me, it says, what's the username? Cisco. What's the password? Cisco. Now it's doing stuff in the background. Let's wait. And it comes back, and it says, here are the commands we gave. Here are the responses. If we go back to the router right now and press enter, look at that. The host name's changed. It's now HQ router. How about that? So we don't even have to have a controller. We don't even have to have a controller to talk directly to our end devices. Really cool. Now, obviously, this is not going to be as flexible as something like NetConf will. We'll talk about NetConf in that video course that you bought. But this is a really simple way for us to go out and just talk to a router. We did not have to be Python experts. We just had to modify a sample program that was given to us. You got to love that. The final topic for today is how to use the graphical interface on one of those controllers and how to use a bunch of the tools built into it. Now, we could spend maybe a few hours talking about the APIC. I thought we would do the APIC-EM today. Now, I've really wrestled with this one, guys. This has been a struggle for me because in order to demonstrate this, I needed to go out. I planned on doing this live for you, but I would have to go out to the DevNet sandbox. The equipment would have to be already reserved. It would have to be available. And I would be doing my streaming video through a VPN connection, and that could lead to problems. There was just a lot of things that could go wrong. So I thought, you know what? I'd like to give you a taste test anyway of what that complete video course is on network programmability. So I want to play you a video which is going to walk you through the applications on the APIC-EM. And this, again, is a taste test from that video course. If you haven't bought it yet, this might help you make that decision. So what I'm going to do is I'm going to put on this video, and it's going to walk you through a bunch of really cool stuff. We're going to be back. We'll take questions, and we'll do one more giveaway. We've got the Switch complete video course coming up. We'll do a giveaway, and then we'll wrap it up for the day. So enjoy this video. I'll see you back. In this video, we want to take a look at some of the applications built into the APIC-EM. And I'm sitting out at the Cisco DevNet sandbox right now, and we visited this earlier on in the course. To get here, you can go as a shortcut to kwtrain.com/sandbox, or you can do an internet search for Cisco DevNet sandbox. But once you get here and get logged in, and you can sign up for a free account if you don't have an account, but once you get here, we want to go into the APIC-EM Hardware Mini Lab 1. Now, things may look a bit different when you come visit this site. The DevNet folks are always making updates, which we love, and it looks like we're running on version 1.4 of the APIC-EM right now. I'm going to reserve this, and it's going to take a little while to get this set up. It's going to reserve it for a couple of hours for me. I'll go ahead and say reserve. And I don't want you to have to wait through all the reservation. So let me just point out a few things when it takes us to the next screen, and then I'll speed the video up dramatically as we go through that waiting process. At this point, the lab is being set up. It's estimating it's going to be complete in about 29 minutes, and we'll not make you wait through that, but I do want to point out a few things. We can see here the topology that we're going to be working with. We've got an APIC-EM, and primarily we're going to be focused on these devices. We've got a Cisco Catalyst 3560X switch, a Cisco Catalyst 3750X switch, and they both connect into a 4451X Cisco router. And we do have a host hanging off of this Catalyst switch. And in order to get in and work with this equipment, I need to have a VPN connection set up. Now, if your email is set up correctly with Cisco DevNet, you should receive an email within this 29-minute window period, and it'll tell you how to log in. It'll say, go to this address, maybe this IP address or this DNS name. Here's the username and password you should use. For whatever reason, I never get those emails, so I want to show you a different way of doing this. I'm going to click on Output, and we can see here on Output, let's get this out of our way for the moment. Here in this Output window, it's going to tell me where I point my VPN client, and it's going to tell me my username and my password, and I'll be able to go ahead and connect. Again, while we're waiting, let's just take a look at a couple of things. I can see here the login credentials for the APIC-EM. I'm going to point my web browser to the APIC-EM, and I'm going to log in with these credentials. We also need to access the switches and the router. So let's scroll up just a bit, and we can click on Lab Architecture Diagrams with Network Element Information. Now, this is not completely accurate. We don't have this Linux server hanging off of the 3750, so pretend that's not there. We do have a server, however, hanging off of the CAT 3560X. But this is going to be a great document to print out because it's going to tell us the IP addresses for, here's the router that we're concerned with, here are the two switches that we're concerned with, and we're going to be connecting via Telnet, notice, and here is the login password credentials. So once we get connected via the VPN, we can point our web browser to the APIC-EM, and we can open up some sort of a terminal window and Telnet to these IP addresses and log in using those credentials. Let's go back over to our main screen, and I haven't received my login or my password information yet, so I'm going to speed the video up pretty dramatically right now. We're going to zip through this waiting period. Well, it's telling us that the lab is ready for use, and notice it gives us some credentials here. I'm going to point my VPN client. I've got a Cisco AnyConnect VPN client. I'm going to point it here. I'm going to log in with this username and this password. And I've got my Cisco VPN AnyConnect client in a different window. So in the background, I'm going to get us logged in. And when you're logging in, it might give you a security warning because we don't have a signed certificate, but I just clicked connect anyway. I've got my username entered. Let me copy and paste the password. Let's see if we can get logged in. All right, I'm connected to the VPN. Let's start accessing some of this gear. Let me close out our output window. Here's what we're dealing with. We've got an APIC-EM. We'll point to that with a browser. And we have a Cisco 3560X, a Cisco 3750X, and a Cisco 4451X. We want to access this router and these two switches. Let's go over to a terminal window and see if we can access these devices. And remember that we'll be using this information to know where to telnet, and here's our login username and our password. So let's go over to a terminal window now, and let's telnet to that Cisco Catalyst 3560X switch. I'll do a telnet to 10.10.20.66. And I've got a username of admin, and I'll enter the password that we saw on that page. And we're logged in. Let's open up another tab. And I'll telnet to the router. I'll do a telnet to 10.10.20.73. Same username. It's going to be the same password. And we're logged in there. And for the demonstration that we're going to be doing, we don't really need to log into the Catalyst 3750X, so I just wanted to make sure that I had connectivity to those two switches. Let's go back to our browser, and I've already pointed my browser to the IP address of the APIC-EM, and because it has a self-signed certificate, we're going to have to say, depending on your browser, that yes, we do want to proceed to this IP address, even though it says it's unsafe. Now, by the way, when you're doing this on the lab, this might not be your IP address. I did this earlier today, and this last octet was 110 instead of 111. So don't try to use the exact numbers that I'm using. Use the documentation that comes with your lab. So let's go ahead and say we want to proceed, and we will get logged in. I'm going to log in with the credentials of admin, and the password is capital C, 1, SCO, 1, 2, 3, 4, 5, exclamation point. And we are now logged into this APIC-EM controller. And remember from our earlier discussion what the APIC-EM controller can do. It can configure devices down below it using southbound APIs, like routers and switches and wireless devices and so on. It can connect to those devices using traditional protocols like Telnet or SNMP. We're not using some sort of open daylight protocol here. We're just using regular protocols that we're accustomed to. And we can do a lot through the GUI. But if we don't want to do it through the GUI, this course is on network programmability, we can do things through the API. And notice here, if I click on API, let's click that, it's going to show us what APIs are available on this controller. And it's a bunch. You can go through here and you can explore a little bit. For example, later in this video, we'll talk about network plug and play, and we can see some of the different APIs. We can say list operations, and it's going to show us the different commands we can send to the controller, and we can send those commands using a Python program. In fact, our next 3 videos in this course are going to use different APIs available on the controller to go out and get some information from the controller. But realize, whatever we're doing here in the GUI, you could create a program to do that. But I want to show you the GUI approach here, and again, in the next 3 videos, we'll take the API approach. But for now, just be aware that you can see what APIs are available by just clicking API. But let's get back to our home page and take a look at what's happening. Here's the overall dashboard, and it doesn't know about any devices attached to it right now. And if I wanted to set up a network plug-and-play device, we'll talk about that later, EasyQoS, we'll talk about these things later. It just allows us to jump off the dashboard and do that right here. I'm going to use the menus along the left-hand side, though. We could check out the system health. We could see if we have any alerts that we need to be aware of. Everything looks green, so that looks good to me. We could look at the system info. This is running on a box that has 64 gigabytes of RAM. We've got a 500 gig hard drive. But that's sort of the overview. Let's start digging in to each of these tools. And we'll start at the top. We really need to start at the top because this is going to do the discovery of the network. Until we discover what the APIC-EM is attached with, we're not able to do anything to those devices. So we'll start out with a discovery. We'll click on discovery. And I'm going to give this discovery a name. I'll just call it Find My Devices. That's just the name I'll give it. And I'm going to use CDP to go out and scour the network. We're going to be able to start on a seed device. I'm going to use that router. And I'm going to say start at that router and then see what neighbors it has. Then go to each of those neighbors and see what neighbors they have. And we can just radiate out from there. We don't have that big of a topology, so it's not going to take too long. But I need to specify what my seed device is. And the IP address of the router that we telnetted into just a moment ago was 10.10.20.73. I'm not going to mess with the subnet filters or the CDP level or anything like that. I'm just going to specify my seed device. And I need to specify some credentials. If you read this document, let's go back here. It tells us that we're using SNMP version 2. It's actually SNMP version 2C, to be picky about it. We have a read-only community string of public, and we have a read-write community string of Cisco 123, Cisco in lowercase. So I need to give those credentials. I want to say I want to add some credentials, and then try to make this a bit larger so it's easier to see. Then I'm going to specify my SNMP version 2C read-only. Notice this is read, this is write. This is going to be my read-only information, and I can give this a name. I'll just call it RO for read-only. Now, here's the community that it told me in the documentation. The community is public. Let's make sure I typed that in correctly, public. And I'll save this as my global setting. It's the same on all of my devices. We'll save that. Let's set up the write community string now. I'll call this one RW for read-write. And this community string is Cisco in lowercase 123. Let's enter that again. Cisco 123. I'll make this global, and we'll save that. those are my SNMP credentials, but I want to give my CLI credentials as well. Let's click on CLI, and we're going to be logging into all these devices using a username of admin. And the password, I'll carefully type that in from the documentation. It's 1, lowercase v, lowercase t, uppercase G, the @ symbol, a lowercase l, a lowercase w, an @ symbol, and a y. Hopefully I entered that correctly. Let's enter it again, being very careful not to mess up. And I don't have a separate enable password. I'll say make this global. Let's do a save. And I've now added my CLI credentials. And when I connect into these devices, remember that this instruction sheet said we're going to use Telnet as our connection. In your environment, hopefully you're using a secure shell, but here we're told we're using Telnet. So I'm going to specify that my protocol is Telnet, and I'm going to deselect secure shell. And now that we've entered the SNMP credentials and the CLI credentials, and we specified a seed device for CDP, we're ready to start the discovery. I'll click on Start, and it's going to take a little bit of time to scour the network and find these different devices. So again, I'll speed up the video, and I'll see you back in just a moment after the discovery has finished. And it says we're complete, and it looks like we connected to all the devices that we were interested in. Not exactly sure what this IP address is. It doesn't seem to appear on this listing, so I'm not going to worry about that when I can get to the devices that I want to access. And now that we've discovered the network, we can get some information via this GUI interface. Let's click on Device Inventory, and this is going to tell us about the Cisco routers and switches it found. We see the IP addresses of this router, a couple of switches, another router. We could also see any hosts that we found. I can click on Host Inventory. It may not show us anything here. Yeah, we had that one failure. That failure may have been the Linux host that was connected off of that switch, so we might need to enter different credentials for that host. But we're not concerned about that host. We're not using that for this demonstration. But if we did have appropriate credentials for a host where we could see it via SNMP, we would get those hosts listed in this screen. Let's take a look at the topology, a nice overview of what's going on. See what we've discovered. Here's the 4551 we're going to be working on. We've got a couple of switches and hubs here. We could say we want to disaggregate those if we wanted to separate those on the topology. But I think this is a great idea. I remember when I used to work down at Disney World, we had a network management system, and it was pretty much unusable when you displayed every single device because I think we had about 600 Cisco routers and literally thousands of Cisco Catalyst switches. You did not want to see an icon for every single device. So it just groups all the switches and hopefully no hubs, but it groups switches and hubs off of that router. And if we want to separate those, we could say disaggregate all. But I think it's great that they sort of consolidate those in the view to begin with. Now, we've taken a look at some information that the APIC-EM has learned about our network. Let's start using some of these tools down at the bottom. These are very powerful. The first one we want to consider is Path Trace, and it's going to allow us to synthetically predict what would happen if we were sending traffic of a certain type from one IP address to another IP address. Now, in our topology, let's bounce back there really quick. I've got this Catalyst 3560X switch. It goes through a router, the 4451X router, and it goes down to the Cisco Catalyst 3750X switch. Let's test this out. Let's see from the perspective of this Cisco Catalyst 3560X, can we get via secure shell to the 3750X? And let's see if we can ping it as well. Let's go over to our terminal window. And let's see if I can ping over to the Cisco Catalyst 3750 series switch. Let's do a ping to 10.10.20.70. Can I ping it? Yes, I can. Can I do a secure shell? I know I'm telnetted in right now, but can I do a secure shell? Let's do an SSH to 10.10.20.70. Yes, I can. Let me enter that same password. And I'll bounce right back out. But I can ping it, and I can secure shell to it. But what if we did this? Let's go back to our topology again. What if I went into this router, and I applied, coming in from the Cisco Catalyst 3560X switch, let's apply an inbound access control list that will permit ping, but it will block secure shell. We know right now ping and secure shell both work, but let's apply an ACL and see if that changes. And then let's see if our path trace analysis tool with the ACL tracking turned on can explain what's happening. But before we do that, let's do a new path trace without an ACL applied. I'll say start a new path trace, And my source is going to be my Cisco Catalyst 3560X switch. My destination is the Cisco Catalyst 3750X switch. And I want to do an ACL trace, even though I don't have an ACL applied just yet. And I want to start the trace. And it's going to take a few moments. Oh, it came back already. And it's successful. It looks like we went from our Cisco Catalyst 3560X through the router into the Cisco Catalyst 3750X. Now let's apply an ACL and see if things change a bit. Let's go back to our router. And it timed out on us, so I'll log in once again. Username is admin. Let me enter my password again. Let's see what interface connects down to that switch. I'll do a show CDP neighbor command. And it looks like I get down to the Cisco Catalyst 3560X switch on gigabit 0/0/1. So that's where I'll apply the ACL. Now let's create it. We'll go into global configuration mode. And I'll say IP access -list. I'll make it an extended list. And I'll call it APIC-EM. And I want to deny just secure shell traffic. So I'll say deny. And remember that secure shell uses TCP port 22. So I'm just going to deny that port from the source of the 3560X going to the destination of the 3750X. So I'm going to deny TCP from a specific host. That 3560X had an IP address of 10.10.20.66 going to a destination host of 10.10.20.70, and we're only going to block that if the TCP port equals, we'll do an EQ, only if it equals 22 for secure shell. Now remember, there is an implicit deny any at the bottom of all our access control lists. That means if I don't explicitly permit something, everything gets blocked. So I need to overcome that. Now remember, the ACL is processed top down. So we're going to hit this deny statement first. So if this is indeed a secure shell packet, then we'll deny it. But everything else will flow through. Let's enter a statement to allow that to happen. I'll say permit IP any. And now we can apply this to our interface. Let's go into interface gigabit 0/0/1. And let's say IP access-group. We'll give the name of the ACL. APIC-EM is what I called it. And it's going to be applied in the inbound direction. Now let's go back to our Catalyst 3560X switch. And let's see if we can do a ping. Can I still ping 10.10.20.70? Yes, I can. Can I still secure shell to it? I'm going to guess no. Let's try. Nope, it says the destination is unreachable. Well, we know how that happened, but let's say we didn't know why that happened. The path trace analysis tool is going to give us some insight. Let's go back over here. I'm going to do another discovery real quick. I don't want to wait for another polling interval. So let's do a discovery. It's going to learn what's going on in the network, and then we'll do a path trace ACL analysis. I'll just select our previous discovery, and I'll say start, and we'll run it again. And we're done with our discovery again. Let's go back to our path trace tool. And let's do a new path trace. This time, we're going to be using just the secure shell port. We'll be using TCP port 22. So I want to do a new one. Start new path trace. Again, it's going to be from my Cisco Catalyst 3560X series switch. And we're going to that Cisco Catalyst 3750X series switch. And this time, I want to say more options. And I'm going to say that the destination port is 22 for secure shell. And the protocol is TCP. Let's do an ACL trace, and let's start the trace. What happens this time? Is it going to work or not? Let's see. This time we have an X telling us that the traffic did not get through. It did earlier. What happened this time? Well, it tells us very specifically that the ingress interface, gigabit 0/0/1 on this router, has an ACL that matched the traffic and it blocked us. We could get more information. I'm going to make this a bit bigger so we can see this. We can get more information by clicking this little plus and saying, I want to view the access control entries that block me. And it shows us the actual access control entry in the ACL that blocked the traffic that we specified. That's powerful. And we did this just with 3 devices. Can you imagine a large network with dozens or hundreds of devices, how powerful would that be to be able to find where traffic is being blocked? Now let's take a look at some of these other tools. Let's take a look at Network Plug and Play. Now, here's a disclaimer on Network Plug and Play. Because we're using the DevNet sandbox to do this, we don't have the luxury of actually having a brand new device that we plug into the network. I'm not able to do that, but I do want to show you how it works. Now, what Network Plug and Play allows us to do is to connect a device to the network and have that device download its configuration from the controller. And also, if it needs it, download its image file, the Cisco iOS image. And at that point, be ready to go without us directly configuring the device. The first thing we might want to do is upload a configuration. Click on Configurations. And I could say Upload here. Now, just another reminder, I mentioned this earlier, but remember at any point, we could do what we're doing on screen through a program using the available APIs. We could use an API that allows us to upload the configuration file, but here, we're just taking a look at doing it through the GUI. I could say upload, and I could upload a file from my computer, and then in a moment you'll see where we could associate that configuration file with a device. We can also specify iOS images. If we click on Images, we can upload an image. They typically end with a .bin extension. And once I've got my configuration and images uploaded, I can go to Projects, and I can create a new project. And again, we're not going to be able to actually do it here because we're not able to plug something into this network. It lives out at the DevNet sandbox. But I could call this Test. I could say I want to add a project. I could specify some additional information here. I'll just create that project. But here's what I wanted to show you. What we could do is we could add a serial number of a device or the MAC address of a device. And we could select the configuration that it's going to download, and we could select the iOS image, if any, that it's going to download. So that's what Network Plug and Play is all about. We upload the images and the configuration files, and then associate the serial number or MAC addresses of devices with those files. Now, one other tool we want to take a look at here, and it's called EasyQoS. With EasyQoS, we're going to be able to create a policy and push it to multiple devices across the network. If we have devices that need a similar or an identical QoS configuration, we can do that with EasyQoS. And I think this tool really illustrates a point we made earlier, and that is a network controller adds a layer of abstraction. In other words, I'm going to say very simply using this interface what I consider to be priority traffic. And to do that, I don't have to know about class maps or policy maps or the service-policy command or the difference between the bandwidth and the priority command. I just say, yeah, these are my important applications. I want to give preference to them. So it makes it super simple. First, I'm going to create a new scope. And I'll give it a name. And I'll call it My First Policy. And I'll click the green check mark to add that. And notice these are the devices that the discovery process found for us. Let's say that I want to apply a policy to my router. I can take my router and just drag and drop it on top of that scope name. And it says one device added to the scope. I could add other devices. I'll just leave it at one for now. But once I've created my scope and I said what devices I want to apply to that scope, then I can go to the application registry. And here we've got different categories of applications that are running on the network. For example, let's click on network control. There are 31 applications that it knows about. Let's say that in our network, we're using EIGRP as our routing protocol. I can select that. It gives us some more information about it. And I can click the star to like it. It's sort of like on Facebook. We can click something to like a protocol. Well, I like EIGRP. It's going to be used in my network. Maybe to go out to my service provider, I'm using BGP. I'll like that one as well. And let's close that one up. Let's do another one. How about voice over IP telephony? Well, I know that my Cisco IP phones use RTP for audio, so I'm going to favorite or like that. I want to give support for Cisco Spark as well as for Cisco Jabber audio. And that's just an example. You would take your time and go through each of these different classifications of traffic and say what traffic is important to you. And now that we've done that, we can start applying policies. Let's click on the Policies tab. And here in the Policies tab, let's say we want to create a policy, and I'll call this Policy_A. And here we have three different categories of traffic that's been defined for us. We've got business relevant traffic, we've got default traffic, and business irrelevant. So that's going to be our lower priority, our medium priority, and our high priority traffic. And notice the applications that I liked, that I favorited, they automatically get added to this business relevant class of traffic. I've got my BGP, I've got my RTP audio, and so on. Now I can drag and drop these back and forth. Let's say, for example, that in my network, scroll down just a bit further and find an interesting one. Here's what I was looking for, BitTorrent. BitTorrent is often used for bad purposes, but it can be used for legitimate purposes. Businesses use it to distribute files sometimes. Let's say that in our network, BitTorrent, it's high priority. So I could take and drag and drop that over here to the business relevant class. So now, all of a sudden, BitTorrent has high priority on our network. And once I'm done, I can say I want to apply my policy. And I could do this at a certain time if I don't want to interrupt the network right now. I could say maybe do it at 2 a.m. tonight. But if I want to apply it now, I've got that option. So it's going to go out and it's going to apply that policy to my router. Let's see what policy got applied. Let's go back over to our terminal window and let's go back to the router. Looks like I'm timed out again. Let's get logged back in once more. Username is admin and I'll enter that password again. And let's see if any QoS policies have been applied. I'm going to do a show class-map. And look at this. I've got lots of class maps that did not exist before. And I know that they were created by EasyQoS because EasyQoS, that's part of the name. Let's look at our policy. I'll do a show policy-map. And we can see what policies have been applied. I said I wanted to give some priority to my voice traffic, and it's applying some best practice recommendations for different traffic types based on those 3 different classes of traffic we had. One more command, and by the way, this is my favorite QoS verification command. It's show policy map interface. It shows us how traffic is classified into a policy and what policies are applied to each interface, and if we actually had traffic matching those policies, it would give us packet and byte counts telling us that. Now, of course, with the APIC-EM, we don't need to go down to this level. I just wanted to give us some verification that EasyQoS, by doing some simple drag and drops, applied a fairly robust quality of service policy to our router. The cool thing is, notice we didn't have to associate this with particular interface IDs because on different routers, maybe I've got different interface identifiers. Do I have to have a separate policy for each router? No, that's the beauty of this layer of abstraction that we're adding with this controller. We're just saying what we want to do to these different devices, and in the background, it goes and does it for us. That's powerful stuff, and that's our look at the APIC-EM. Hope you enjoyed that look at the APIC-EM. And we're just about done. I know that some people are having to drop off because of the late hour or early hour where they are, but we're going to wrap up here in just a few moments. I want to give another Q&A break or another Q&A to wrap it up. We're going to do another giveaway. And let me bring my slides back up real quick for you. 1 second while I do that. Here are some book recommendations that I promised you. These are books that I personally own and have used in the development of the course that we've been talking about. Programming and Automating Cisco Networks. I've got a lot out of that book. That's been a super valuable book. I highly, highly recommend that one. So I would definitely recommend you check that one out. The Policy-Driven Data Center with ACI, which will focus more on the APIC. That's another one that I've used quite a bit. So I recommend those two if you want to jot those down. Also, for your Python study, one that I sort of went cover to cover with is Learn Python in One Day and Learn It Well. That is a great introductory text to get into Python. And one that I've used, I haven't read this next one cover to cover. It's more of a reference that if I need a function that does something, I go look it up in this book and it gives me a lot of great insight. It's the Python Crash Course. So those are a couple of books on network programmability, a couple of books on Python that I would recommend. I've mentioned a time or two my Diver Down routing and switching group. It's sort of my inner circle where we get together once a month on a live webinar. People ask their questions about whatever. And we call it Diver Down because we go deep into some of these topics that you might just hit at the surface level in your studies. And we don't just talk about technology. I mean, for the last 2 sessions, we've been going deep into spanning tree. Before that, we did BGP. But when Chuck Robbins came out with his idea of the hybrid engineer, these people were the first to know about that through my communication. And we also talked about when Cisco had a big layoff. We talked about why that's happening, what's going on internally with Cisco, what to be thinking about for the future. So we talk about a lot of things surrounding your entire career. And in fact, what's coming up for the December session, if you want to go ahead and get it now and attend the December session, I told all the members to come with their number one career goal. And we're going to talk about career goals next time. And we're going to say, all right, here's where you are. If I were in your position, here's what I would do next. We can get feedback. We can collaborate with other people that are on the call. So we're going to be talking about careers, and I'm going to be talking about how to get experience if you don't have the job. I'm going to be talking about how you can full-time or on the side set up your own network consulting business. So that's something that I've never taught publicly before. So that's going to be exciting. If you want to get in and interact with us on that level, this program, we do it once a month. You've got recordings replay recordings to past sessions. Here's the link to sign up today to get your bonus or to get your discount. Go to kwtrain.com/BF for Black Friday, DD for Diver Down. So it's BFDD. Normally, this is going to cost $49 a month. Now, if you go out to my website right now, you'll see that, hey, it's 50% off of all my stuff for Black Friday. You enter the code and you would get half price for 1 month, but then it goes back to $49. But using this link on screen, as long as if you want to stay in it for 5 years, that's great. What you can do, if I can get this to click, is sign up using that link, and you get it for $37 a month. That's $12 off. It's like $144 savings a year, and you'll lock in that price for as long as you stay a member. Now, there's no obligation. If you take it a month and want to get out, that's fine. You can bail at any time. There's no year commitment or anything like that. But people tend to stick around because they get a lot of value out of it. But this is your one opportunity to get that at a pretty significant discount that locks it in for forever, as long as you want to stay enrolled.